Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the October-November 2022 paper 3 variant 3 from Cambridge, the International A-Level Exam Board. And this question here is about complex numbers and solving equations involving complex numbers. So it's a question that's not really that kind of common. And I think a lot of students were kind of like thrown off by this question. Okay. So it says solve the quadratic equation. So they tell us it's a quadratic equation, all right, giving your answer in the form x plus I, y, where x and y are real numbers. So our answer is going to be z equals something of this form, x plus iy, where you have a real and an imaginary part. It's going to be a complex number. So if we look at this, we have something times z squared, and this something is a constant. It's a number. It's 1 minus 3i. I is a constant. It's just a number. It's just a imaginary number. That's all. Its value is the root of -1. And this is another constant times z, and then you have a constant equals 0. So we can see it's of the form, like you think of az squared plus bz plus c equals 0, where z is our constant that we're trying to find, our variable that we're trying to find the values of, right? So it's a quadratic equation, and we could use the quadratic formula to try to find the values of z. So if we use a quadratic formula, we have our a value is going to be 1 minus 3i. Our b value is going to be negative 2 plus I. And our c value is going to be I. And using the quadratic formula, we'll say z equals minus b. So minus b, which is, now remember the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. I think that's even in your formula sheet. Right, z equals minus, so we can, our x is z now, so z equals minus b, so it's minus this, so it's going to be basically, it's going to be 2 plus I, because the minuses will cancel out. So that'll be 2 plus I, plus or minus the square root of b squared. So when you square this, the minus again will cancel out, so you'll have 2 plus I squared. The minus is going to become plus anyway, so we can ignore that. Plus or minus, b squared minus 4 times a. A is 1 minus 3i times I. 4ac, all of that over 2 times a, which is 2 times 1 minus 3i. Okay, so now let's try to solve this. So we have z equals, we have 2 plus I plus or minus the square root of. Now let's try to simplify this. So 2 plus I all squared is going to be 4. Square the first term, plus multiply them together and double it. So it's going to be plus 4i and plus I squared. And then you're going to have minus 4 times I. So it's minus 4i times 1. And you have minus 4i times minus 3i. That's going to give you plus 12i squared. Minus 4i times minus 3i is minus 12i squared. Okay, and all over. Now I'm going to leave this in this form. I don't have to multiply by 2 right now, in case we might, this form might be useful for us. Okay, so now let's understand that I squared is equal to negative 1. That might help us to simplify some of them. So z equals 2 plus I plus or minus the square root of, and you have 4 plus 4i minus 1 minus 4i, and you're going to have minus 12 all over 2 times 1 minus 3i. Okay, now Next, well, we can continue trying to simplify this. Let's see what happens next. So we have z equals 2 plus I, plus or minus. Now you're going to have 4, plus 4i and minus 4i cancel out. We have 4 minus 1 minus 12. So that's going to be 3 minus 12, which is minus 9, minus 9. So you've got the square root of negative 9 over 2 times 1 minus 3i. Okay, and we know that the square root of negative 9 is like this. It's like the square root of I times the square root of 9. So it's going to be basically 3i. This is 3i. Okay, so this is going to become 3i. Okay, because minus 1 is equal to root of I. Okay, the root of I is equal to minus 1. So the minus 1 became minus 1, root of minus 1 times root of 9, which is going to be I times root of 9, which is 3i. Okay, so that becomes 3i here. So you have now z equals 2 plus I plus or minus 3i, all over 2 times 1 minus 3i. So now let's simplify that a bit further. So we have two different answers. This can either be 2 plus 4i over 2 times 1 minus 3i, or I'm going to have 2, and you have I minus 3i, so 2 minus 2i over 2 times 1 minus 3i. Okay, so now we have to leave our answers in this form, x plus iy. So these are our two solutions. However, we want to simplify them and write them in that form. So we can do two things. So let's look at the first solution. I'm going to take out 2 as common from the numerator. So I have 1 plus 2i over 2 times 1 minus 3i. The 2's will cancel. And the same thing for the second solution. We have 2 as common. So we have 2 times 1 minus I over 2 times 1 minus 3i. These 2's will cancel. Okay, and now what we're left to do is we're left to realize, make the denominators real. When we make the denominators real, we'll end up with something in the form required. So I'm going to take this and I'm going to multiply the numerator by 1 plus 3i, because that's the conjugate of this. That will get rid of the complex number, the imaginary number part. So I'll put 1 plus 3i, and I'll do the same thing. I have to multiply the numerator by the same thing that I multiplied the denominator. And same for z2. I'll have 1 minus I, and this is 1 minus 3i. Again, I'll multiply this by 1 plus 3i, both numerator and denominator, to get rid of that, to get rid of the complex number in the denominator. So now, this will give me 1 plus 3i plus 2i, that's plus 5i, and it's going to be plus 6i squared over, and this is going to give me 1, and you're going to have 1 minus 9i squared. And here I'll have z2 equals, this is going to give me 1 plus 3i minus I minus 3i squared over, and this is going to give me, again, the same thing, 1 minus 9i squared. Okay, so remember, I squared is equal to minus 1. So our first solution, Z1, is going to be, I'll have 1 minus 6, which is minus 5 plus 5i over, remember, I squared is minus 1, so it's going to be 1 plus 9, which is 10. And my second solution for z is going to be 1, remember this is minus 1, so it's going to give me 4. I'll have a 1 plus 4, because it's going to become minus 3 times minus 1, which is plus 3. So 1 plus 3 is 4. And I'm going to have plus 2i over, again, it's going to be 10. Because this is minus 1, so you'll have 1 minus 9 times minus 1, okay, which is 1 plus 9, which is 10. So now we're almost there. I've kind of run out of space. Okay, so now I'm going to split this up into two parts. You'll have minus a half plus a half I. And here I'll have Z2 is going to be 2 over 5 plus 1 over 5I. And there I have finished. Okay, this is the end of this question. So that completes this question. We have Z1 equals minus a half plus a half I. And the other Z value is 2/5 plus a fifth I. So this is question which a lot of students didn't know really how to start, okay, but it's pretty straightforward once you realize you can just use the quadratic formula to solve it. It's pretty straightforward. You just have to remember that I squared is equal to -1, and that you have to rationalize, or not rationalize, you have to realize, make the denominators real by multiplying them by their conjugates, and to get the answer in the form required. Okay, so that's something that we can, sometimes you see a question that's not familiar. You don't see many questions like this, for example, but you have to just think, a bit clearly. It's a quadratic equation, and they're just complex numbers. They're actually constants. So you can apply the quadratic formula to it, and it works. Okay, so there's the answer to this question. Other questions from this paper can be found in the playlist, which will appear at the top right of this screen, end of the video. Other questions dealing with complex numbers in general, you can find in the playlist over here. You can subscribe to my channel by clicking on this link, and the video at the top, link at the top of here, will show you how to use my channel to find the things you might be interested in. Thank you for watching, and see you soon.